Alright, moving into section 10.3, we're going to focus in on arcs and chords and their relationships in 10.3. So a lot more algebra going on in this section for sure. So here's kind of the main relationship that we're looking at for this section. So again, keep in mind, guys, what a chord is. A chord is any segment that goes from one point on the circle to another point on the circle. So that would definitely represent a chord. An arc is the piece of the circle sectioned off by that chord. So this would be chord RS, this would be arc RS, right? So the portion of the circle is the arc, the segment is the chord. So here's the rule that they want us to learn today, and this is what they're describing to us right here. So obviously within this you can see two chords, so RS and TV are both chords. Well, what they're trying to tell you is if those two chords are equal, so if RS is congruent, pardon the bell, if RS is congruent to TV, well then what else must be true? What they're saying is if those two chords are congruent, well then their arcs, arc RS and arc TV, would also be congruent. And it works both ways. Okay, so you can say that either direction. So if you know that these two chords are congruent, then you're able to say that the two arcs are congruent, and it goes the other way. If you were to say that these two arcs are congruent, then yes, it does make the two chords congruent as well. Okay, so here's just a basic example they put together for us, and then we're going to try a bunch on our own. So as you look at this, you can see that it was given information that these two arcs are congruent to each other. So they said that arc DC is congruent to arc AB. Therefore, we're allowed to say that the two chords are congruent. So 2x plus 3 must equal 8x. All right, and so that was the setup they used over here, and then solving for x, very basic algebra to solve for x. Guys, here's one thing that is so important that you read careful. So many times students will stop here and give this as their answer. Make sure that you read what they're asking for. Sometimes that's what they want to know. Sometimes they just say solve for x. But that's not what this one says. This one says find AB. So we have to take that 1/2, plug it back in for x in order to figure out the length of AB. Okay, so if we did 8 times 1/2, that tells us that AB is 4. So make sure that you go all the way through with what they are asking you to find. That's super important. These ones, however, do say solve for x. So we're going to solve for x. So here's what we got going on. Guys, this does combine a lot of what we learned in our last lesson into some of these drawings. So as I look at the drawing here, I can see that I have RS, that's a chord, and chord TS are congruent to each other. Those marks tell me that they're congruent, which must mean that this arc is equal to this arc. So if this arc is x, then we know that this arc is also x. The major difference between an arc and a chord is that a chord is measured as a length. The arcs can be measured as a length or in terms of degrees. So in this one, you'll notice by the degree symbols, they want us to look at x as the degree measure of that arc. So as I look at this, let's put this together with what we learned in our last lesson. I know that the entire circle must add up to 360 degrees. So that means that x plus 64 equals 360. Squeeze it in right there. So there's our equation. All we got to do now is use some basic algebra to solve it. We know that x plus x is 2x. So we just combine like terms. Subtract 64 from both sides. And we're going to get 296. And then divide both sides by 2. So x equals 148. And again, guys, that's all they asked for on this one, is solve for x, but always check, right? Make sure that we know what they're asking for. It's really important that we read those directions carefully. Let's move on to the next guy. All right, so another thing that we learned in our previous lesson, I'm going to switch colors here so we don't confuse which one we're doing right now. In our previous lesson, that we know that this is what we call a central angle, right? A central angle is an angle that's formed with the center, right? So this is one that's formed with the center. We call this a central angle. We know that a central angle is equal to the measure of its arc, right? Which must mean that if this angle is x degrees, then its arc is also x degrees. So, what does that make x? So as I look at these two chords, I can see that these two chords are congruent, which must mean that their two arcs are congruent, which must mean they both are 116. So we know that this x would have to measure 116 degrees. All right, let's go over to number 3. Guys, I'm just going to keep going through a bunch of these because I want you to see multiple examples here, because there's a lot of little differences, like little different ways that they're going to give you information, and I want to make sure you're getting a lot of exposure to those. Here's one that is very basic, right? Very basic. So as you look at this one, obviously JK and LM are congruent chords because they're both 4. So if those two chords are congruent, we know that the measure of their arcs are also congruent. All right, so as we look at these guys, they would both have to be 82 degrees. So that tells us that x is 82 degrees. And some are very straightforward like that, which are kind of nice. Others, you have to make some setups with equations or using some previous rules to replace your x. Let's jump down to this guy. Guys, at any time, it's a great thing to pause the video and try these on your own ahead of me for some practice. This one is very similar to number 1. Right? I can tell that these two chords are congruent, which must mean that the two arcs are congruent. So if we can call that one x, that means we can also call this one x. And now we're back to our previous lesson that says all the arcs of a circle must add to 360. So we can say that x plus 90 equals 360. So basic algebra, x plus x is 2x. Subtract 90 from both sides. Put you right here. Divide both sides by 2. And we should get x is 135. All right. Let's go over to this one. This one is similar to the example they gave us. We can see that these two arcs are congruent, which must mean that their chords are congruent. So that must mean that 2x plus 4 must equal 18. So basic algebra again, 2-step solve, subtract 4, and divide by 2. All right, last couple on this side here. So again, as I look at these, real similar idea. I can see that the two chords are congruent. They're both 6. That must mean that these two guys are equal to each other. So we can now say that 2x plus 4 is equal to 3x plus 2. Let's get our x's onto the same side. So if we subtract 2x from both sides, it's going to put us right here. And then subtract 2 from both sides, and we have our x. Guys, again, read careful. This is one of those where they could easily say, what is the measure of arc NL, right? In other words, they might want me to take this sometimes and plug it back in for x to get the measure of the arc. So just read careful and look out for stuff like that. All right, so here's sort of an addition to the rule, right, that I want you guys to see. Notice on this one that they are saying that the two circles are congruent. They're the same size, right? So as I look at these, you guys see how those two arcs are congruent? So remember, if two arcs are congruent, that must mean that their chords are congruent. But that's only true if they're within the same size circle. So they either have to be in the same circle, like all the other ones have been, or they have to come from the same sized circle, which these two are. These are the exact same circles, right? So the rule still applies in this case because they are the same size circle. So that now we can say, well, if those two arcs are congruent, then this still makes these two chords congruent because they're coming from the same size circle. So that allows us to set up that equation, subtract 2x from both sides, and divide by 4. All right, let me flip this over. All right, so 3 main rules that we're going to look at right here that are bullet pointed. Guys, if you're taking your own notes and you don't have my notes, you need to write these out. Okay, this is a very important concepts for section 3 here. Here's the first one. So we're just going to kind of talk through these, and then we're going to do some examples to follow. So in the circle, so if a diameter or radius is, here's the key, is perpendicular to a chord. So if you look at this drawing, you can see that here is a radius, OW is a radius. And they are telling me that it is perpendicular to chord AB. All right, we can see by the right angle mark right there. So when that happens, here's the result. It bisects the chord, and it bisects the arc. Remember what bisects means? Go back to first semester here. Bisect means it cuts it in half, cuts it into 2 equal parts. So that must mean that in this case, as soon as I see that little right angle, that now tells me that AX is congruent to BX. They're equal. But it also tells me that the arc was also bisected. I now know that AW is congruent to BW. So I'm actually getting 2 pieces of information here out of that one little mark that they gave us. All right. So in a circle, the perpendicular bisector of the chord is the diameter of a radius. Here's what they mean by that. It's sort of the converse of this, right? They're saying, well, what if you know that AB was bisected, and if you know that OW is, or even this one, ZW, is perpendicular to that chord. So if it's perpendicular to the chord and it bisects it, if both those things are true, well then the segment you're talking about has to be the radius, or it has to be the diameter, right? That's kind of the converse of that statement. So here's the third one. So 2 chords are congruent if and only if they are equidistant from the center. So here's what they're saying. If you look at chord AB and chord RS, those guys are congruent if they are the same distance away from this point right here. In other words, if XO is equal to YO, then you're allowed to say, okay, that must mean that AB is congruent to RS. So those guys are equal if they're the same distance from the center. Guys, the opposite of that is also true. Or I should say the converse. Because of this little phrase right here, what they're telling us is that the converse is also true. If RS is congruent to AB, well, then they're the same distance from the center. So if you know that RS is congruent to AB, then you're allowed to say, well, then YO is congruent to XO. So we're allowed to kind of come at it from both ways. Let's look at a couple examples. All right, so here we go. In circle O, CD is perpendicular to OE. So here's circle O. They're telling us that, I'm not trying to draw on this without destroying their circle, that is perpendicular to CD. They already marked that for us, right? They marked the little right angle to show that they are perpendicular. So that's already been marked. I'm going to darken it to make sure we recognize that. So that's already been marked. Now they're telling us that OD is 15. So OD, the radius, is 15. Remember, that's a radius because it goes from the center to a point on the circle. They're also telling me that CD is 24. So that whole chord is 24. Okay, here's what they want us to get out of this. Because OE is perpendicular to that chord, and obviously it comes from the center, that must mean that it bisected the chord. So CD just got cut in half. right? This guy is being bisected. So if the whole thing is 24, what does that make ED? It would have to be half, right? Because if the whole thing is 24, we break that up into 12 and 12. So that allows me to say that information right here. Guys, obviously a big connection here is coming back to right triangles, which was such an important chapter, chapter 8. So we're back to some Pythagorean theorem in order to come up with OE, right? So I'm not going to work all that out because they did that for you right here. I just wanted you to see that as an example, okay, and how we're using basically this new rule along with some of our old rules, right, that we're kind of combining all those concepts together right now. Okay, let me go down to our final couple examples here. Let's do some practice on these. So in circle P, the radius is 13. So if you look at this one, the length from P to O is 13 because that's a radius. RS is 24. Find the measures. So let's just look at this for a minute. So let's apply the new rule. I have a radius that is perpendicular to a chord. So remember, what does that do to the chord? It bisects it, right? It cuts the chord in half, which means that RT has to be congruent to ST, right? It was bisected, it was cut in half, so if the whole thing is 24, that means each part is half of that, because it was bisected. So those guys are both 12. So what can we do with all that? Guys, this is one that really trips people up. Let me do the easy ones first. RT. We just figured out that RT is 12, right? Because the chord was bisected. RT has to be 12. What about PT? How am I supposed to get that length? That one's a tricky one. And then they want us to get this guy, TQ. So basically, here's the radius, PQ. All right, that's the radius. So they want us to find each little portion of that radius. Well, up here they told us that the whole thing is 13. So the distance from P to Q is 13. But how are we supposed to use that to get that little segment and this bigger segment right here? So here's a key step in this that oftentimes people don't recognize that you can do. Remember, PQ is a radius. A radius can be drawn anywhere. So what if we drew the radius from P to S? What if we saw that as the radius? Because we already know that PS is equal to PQ because they're both the radii within the same circle. So that means if PQ is 13, PS is also 13. Right? So now we can finish it off with some good old Pythagorean theorem, because now I'm looking at a right triangle. Right? So it's like a squared plus b squared equals c squared. So if we did a little Pythagorean theorem, we'd figure out that PT is 5. Try to squeeze that in there. So that's PT. So if we did Pythagorean theorem, we would figure out that PT is 5. So what does that make TQ? Well, remember, the whole thing is 13. It's a radius. Right? So if that radius is the whole thing is 13 and that much is 5, what are we left with for TQ? Right? The remaining amount would have to be 8. All right, so that's a tough one. Just remember on that one, the key is to draw the radius in such a way that it actually helps create that right triangle that we're working with. So let's try these last couple. Here we go. So in this one, they're telling us that the diameter is 12. So from B to E is 12, which obviously makes the radius 6. So from AB would be 6, and from AE is 6. They're telling me that arc CD is 90 degrees, right? Arc CD is 90 degrees. So from the measure of from here to here is 90 degrees. Find each measure. So if arc CD is 90, what would DE have to equal? Well, remember, one of the things that we looked at a second ago is when you have a diameter that is perpendicular to a chord, it's perpendicular to that chord, two things happen. The chord gets bisected, and its arc gets bisected. So if this entire arc is 90, well, then this would have to represent half of that arc, which would be 45. So this guy is 45 degrees. Remember, whenever you see the little m, that means the measure of something, which we always measure in degrees. What about FD? What is the length of FD? That half of the chord right there. So they told us right here that CD is 8. So here's CD. And as we just mentioned, because the diameter is perpendicular to this chord, it cut the chord in half. So if this chord was CD, that means this half is 4 and this half is 4. All right, how about AF? So the little segment from right here to right there. Guys, this is just like what we did in the last problem. I want to redraw the radius to show the right triangle. So this radius, like where you see AB, couldn't we also draw the radius right there and create a right triangle? Absolutely. We just showed that up above, why that would work. So if the diameter was 12, well, that would make a radius 6, because the radius is always half the diameter. We also figured out that because of this information, that CF is 4. And so now we can use some Pythagorean theorem to come up with AF, which would be the last leg of that little triangle right there. So let's say, I'll call it A. A squared plus B squared equals C squared. So if we did a little solving on this, so let's see, 36 minus 16, because I'm subtracting that over, would be 20. So A is the square root of 20. Guys, on this one, follow directions. If they said write it in simplest radical form, you should be writing it like this. All right, that would be simplest radical form. If they said nearest hundredth, then go ahead and type it into a calculator. I'm going to say, what's the square root of 20? 4.47. So read directions carefully. Last one, in circle R, TS is 21. So that guy's 21. UV is 3x. UV is 3x. Those are both chords. What is x? So here was one of the other rules we talked about. Guys, TS and UV, if you notice, they're both 6 units from the center. So we looked at up above on this page that if two chords are the same distance from the center, like these ones are, well then the chords have to be equal to each other. So that tells me that TS has to be equal to UV. So they said TS is 21. They said UV is 3x. Those guys have to be equal since they are the same distance from the center of the circle. So if I divide both sides by 3, we figure out that x is 21. All right, that's going to do it for 10.3.